Good evening. Tonight we'll be talking about Python errors and exceptions. So for this series, I am expecting that you already know Python. You've written quite a lot of Python. You know the syntax, are familiar with general usage and general patterns. Have read a few peps before. So what I'll be talking about is some of the more opinion-based things to say, how I've seen these things done before, the patterns that I've seen that I use. I will give my personal opinion on them, and talk about how the Python language and the Python community generally treats these type of subjects. Because as of course, with Python, if it's not a PEP, it's entirely up to you. It's up to your code base, how you want to do things, how you want to treat things. And as long as you are consistent, that is the right answer. But here I'll just be talking about how, again, patterns that I've seen in the past that maybe will save you some time Googling later. So today we're talking about errors and exceptions in Python, because how we do these and our opinion towards them is slightly different from other languages. So in another language, take a Java or C++, you'll generally have two ways of handling some type of error case when you're writing your code. You can either raise an exception, or you can return an error code or something similar of that. I think Go also has a built-in way to return a specific error type that you can check outside of the function. Rust has its result type, which can you can be either okay or error, and you can run a match on that. That kind of acts as sort of a try except. Well, Python is a little bit different in that its mantra is it's easier to ask for forgiveness rather than look before you leap, which is a lot of other C-based languages tend to do. So in general, in Python, you'll see try excepts and error handling and errors and exceptions a lot more often than you would in other language, because they're actually a little bit more efficient, which we'll get into that because it's got some gotchas. So first off, the difference between an error and exception in Python. So errors and exceptions from a technical perspective are entirely the same thing under the hood. So here I've already created a test error and a test exception. You'll see that both these inherit from the base exception. This is entirely acceptable practice when you're actually creating your own errors or exceptions. It's all about how you treat them. And again, it's as long as you're consistent, that is the correct answer. But in general, people in Python do treat them differently in what they expect the caller of your function to actually do with them. So both cases do represent, somewhat unrecoverable states. It means that a function you are writing, if you're raising an exception or an error, it means your function isn't able to actually do the job that it is set out to do. So it's something that either has to be caught or needs to be bubbled up as a purely fatal event. But in general, you'll see errors account for things that are more programmatic, in that you'll see examples like value error. These are typically used for one example, if I pass an argument into a function and the value of it doesn't make sense for me to compute on. If you're using untyped Python, it may be the wrong type. Or if you have some type of validation you're doing, you may use that. In the Pydantic library, they use value errors to try to sort of translate custom validation into the Pydantic framework. So things like that. You also have key errors for dictionary. This is you're looking for a key and you can't find it. Other things like out of memory errors also exist, if I can spell it right. Out of memory errors also exist when, for example, your program or some aspect of it that's trying to use more RAM than it's supposed to fails to allocate what it needs, and it therefore can no longer run. So these are things that the code is syntactically valid and it's trying to run, but of course it can't. And generally, these are seen more often. So things like a key error you'll see very often in dictionaries, and you catch them in a lot of different cases. Value errors, like I said, happens with validation of arguments when you're validating at runtime, which given Python is interpreted is most of the time. There's also generic runtime error, which can do anything generic that you want it to. These are things that you'll generally expect the user to catch, and you'll notify them about in the contract of your function. However, they get that, whether it be documentation or something else. and expected to come up, relatively often. And then exceptions are used for truly exceptional cases. Things like I'm trying to execute your program, and the Python interpreter wasn't able to actually allocate enough memory to run at all. There are things like when you're dealing with cloud providers, you'll see lots of exceptions about networking, and it can't actually contact the endpoints they're trying to get it to. You'll see the same thing with requests when you're making your requests. So things that are more environmental in nature. And again, this isn't an absolute. This is just, what I've generally seen and what I've, researched myself, as well as opinions that I've heard. But again, it entirely depends on the library, on the provider, on whoever's writing the code, and how they're used. But that's generally how I've split them apart. Errors are generally things that are very programmatic in nature, versus exceptions are environmental, truly exceptional cases that you wouldn't expect to happen. And therefore, you might see someone catching errors a lot more than you might see them catching exceptions. But it entirely depends. So a big difference from Python and other languages is you'll see, and again in a lot of other C-like languages, you'll see people talk about how try excepts are very very expensive, in that you want to try to avoid them and avoid raising exceptions too often, because they actually cause the program to quit, and then there's code that actually catches that and then resumes the program execution. In Python, they have optimized for this. So while that is actually still the case in the interpreter itself, that an exception or an error when you raise it halts program execution, they've done it in such a way that if it's not coming up very often, then in newer versions of Python, it's actually zero cost. So it runs as if there was no check at all. Versus in older versions of Python, it still optimizes for the happy path. That exception doesn't come up. So there is still like a little bit of overhead, but it's not very much at all. In fact, it's actually less than an if statement in general. And because of that attitude, try excepts in Python have been implemented as their own form of control structure. So let's say I'm dealing with a dictionary, and I've got some value, and I give it a value, and I want to check, or I want to do some processing on this dictionary, and I want to check if a certain key exists. So I might say something like, my new val, and then we'll give it this key, my new val, and then I simply want to print. This value. Well, of course, this key doesn't actually exist in the dictionary, so of course we expect this to raise an exception, and it does. It raises a key error. So at this point, my function, I've kind of written it just generally in this file. But imagine this was in a function, then this is an unrecoverable state. I've written code in a way that once I hit this error, nothing can really be done about it. So of course, I can wrap this in a try except. And as good practice, we're going to make sure that we actually catch the specific exception that we're looking for. We'll just simply print, this key didn't exist. So now, as one might expect, we run our program, and it exits successfully with a nice printed error message that says, well, this key didn't exist. Oh dear, that's a problem. And one note, notice that we did catch the error relevant to what we were looking for. It's very specific. So this actually carries over from any other language you might see, in that you want to try to avoid catching general exceptions as much as possible, so you can react to them in the proper way and make sure if something else is thrown that might be more unexpected, that you're not allowing the program to resume in places you might not want it to. Like in this case, it's very simple. I'm catching a key error. That's the only exception that might pop up here. And so I could theoretically just accept exception and not care. Um, but in more advanced cases, you do want to make sure you make that distinction of this is I can specifically handle this type of error and I can adjust what I'm doing at runtime as opposed to something that comes up and you have no way to actually recover from it. But anyway, so back to this, and I've got my error I printed. Fantastic. Now, as part of actually implementing as a control structure, we can actually treat this very similar to an if statement, where we actually use the try sort of as a true value for an if statement, where the accept is sort of the else in a sort of way. So let's say I want to do something and say I really only want to print so long as this key actually existed. Well, we can actually tack an else on here. And we can print my new val. Notice the scope remains the same. Of course, in Python, try accepts not established scope. So you can define new variables within try blocks and make sure that the scope remains the same throughout. So you'll notice here that once again, it didn't exist. Oh dear. Now let's change it to a value that did exist. And now I've actually printed the value that's in the dictionary. So this is how it's implemented sort of as a control structure. So if the try succeeds and there was no issues, then I'll run to the else. If it didn't succeed and I raise an exception, then I just print, something wasn't handled properly. Now that we've covered try, except, and else, just like other languages, Python also has a finally. And finally will execute every time, no matter what, whether the try block was successful or not. So whether there's an exception raised or not, whether the else executed, doesn't matter. The final will happen every time. So in this case, I am getting the value from the dictionary. This should be successful because this key exists. And we're then printing that value. And then in the finally, we're just printing I'm done. So we run this. And cool. We see both the value printed as well as I'm done. Now, if we actually change this to a different key again, then we should see both the error caught and the message I'm done. So it's pretty powerful. You can actually drop in try excepts as if statements in a lot of cases where errors might be generated. Now, you wouldn't want to do that every time. But in cases where you're trying to catch specific scenarios, it can be very useful. So before we close out, the last thing to discuss, of course, is I mentioned the optimization around try accepts as a control structure versus if statements, which is a little bit against what other languages might think about that. In newer versions of Python, they've implemented something called zero cost catching, meaning that if I'm executing code in a try and that try is successful and I go and execute an else, it is actually faster than if I were to use an if statement to then check beforehand. Because I didn't actually make any additional check. I didn't actually take the time on the CPU to do anything for that. I just executed the code in the path that it was in, and it was all successful. And so I was able to skip an entire section. Versus if you were to implement that as an if statement, of course, you have to check first before you go and execute something. That's sort of, look before you leap. Versus in Python here, use a try except. It's more easier to ask for permission. But of course, that only really applies if there's actually an exception or an error to catch. You wouldn't want to just wholly replace try excepts for if statements all the time, because of course, it's the balance of optimization versus readability. And try excepts, in my opinion, are a little bit hard to read and reason about when you're first looking at new code versus an if statement. When it comes down to those kinds of optimizations, or you're trying to catch these exceptions, then it's wholly acceptable to do that. Great. So I think that's it for me. Leave in the comments any questions, comments. If you completely disagree with me, then feel free to argue to your heart's content. But again, this whole purpose of this was to show my opinion, how I generally think about things, and my research on how the Python community has done it and how I've seen it done before. So Everyone has their way, so long as your code base is consistent, then that's the most important thing. Great. All right. Thanks.